morning, everyone. Today we're going to talk about polyatomic ions. Now, I'm not going to pause. I'm going to just go through it. So if you want to get the note, you can take a look at the PDF. So polyatomic ions. So first we're going to name these compounds. These are from yesterday. So here we have NaCl. And NaCl, okay, this is your metal, and this is your non-metal. Okay, and that's how I can tell it's ionic. So I have to do the rule. You name the first metal first, then the non-metal, and I have to change the ending to IDE. This is a metal and this is a non-metal. So this is calcium oxide. This is a metal and this is a non-metal. So this is magnesium fluoride. So what I'm looking for is the IDE at the end. So polyatomic ions are ions that are composed of more than one kind of atom. These groups of atoms tend to stay together and carry an overall charge. This is the difference. It's already an ion, but it's got two or more elements already attached, and they carry a charge. So processed foods contain a lot of sodium, mostly from sodium chloride. Sodium chloride enhances the flavor and extends the shelf life of food. Other additives in processed foods also contribute to your daily sodium intake. Preserved meats, such as hot dogs, stay red due to the addition of potassium nitrate and sodium nitrite. So this right here is a polyatomic ion, and so is this. Okay, so we deal with these types of chemicals in our food. All right, and here are the polyatomic ions we're going to be looking at. This is ammonium, okay, and what you can see is we have a nonmetal bonded with a nonmetal. All right, poly means many. So as you can see, it already has a charge. That charge is for this whole thing. We have carbonate. Again, this whole ion here carries this charge, and so on. We have hydrogen carbonate, or what we call bicarbonate. That's what's in Tums, okay, to neutralize acid in our stomachs. Okay, and you can see that there's 3 elements in this one. Okay, but they're grouped together and they have this overall charge. Next, we have a hydroxide, nitrate, nitride, permanganate, phosphate, phosphite, sulfate, and sulfite. Okay, I am never going to be able myself to memorize everything unless you're using it every day. So what I've done is on your periodic table, okay, I've put them on here. Okay, so here is your periodic table. Okay, if you look down at the bottom, you will see the polyatomic ions. Okay, so the chart that I just showed you is actually on your periodic table for your own reference. Okay, and you're to be using this chart today. Okay, so if you don't have your periodic table out, I would get it out now. Okay, so here are some polyatomic ions. So we have NO3. So this is what it looks like when it's bonded. Now, since it's an ion, it has those brackets with the overall charge. So everything inside that bracket has that overall charge. Here's SO4 with a 2 negative. Okay, and the same thing. I'm not going to ask you to draw these ions. It's just so that you can see that this charge applies to everything here. So there's many types of polyatomic ions, but one special group should be mentioned. Oxyacids are compounds formed when hydrogen combines with polyatomic ions that contain oxygen. Okay, we're going to be dealing with acids and bases. But for example, here's a nitrate, okay, and when a hydrogen attaches to it, it becomes nitric acid. Nitrous acid, the nitrate ion bonds with a hydrogen, and you get nitrous acid, and so forth. When we do get into acids and bases, again, on your periodic table, I provided you with a chart, okay? We're not going to be really dealing with these today. In another lesson we will be, but they're here for your reference, so there's no searching up and you don't have to memorize it. It's right here, okay? Okay, so some polyatomic compounds. So what they are, they're pure substances that involve combinations of metals with polyatomic ions. Okay, so for example here we have calcium carbonate, and that's found in chalk and building materials. So you can see here's calcium, and this is the carbonate polyatomic. Then we have magnesium hydroxide. So here's our metal, magnesium. This is the hydroxide ion that it is attached to. Okay, this is a stomach in acid. You have sulfuric acid, we talked about that, that's a carbatory acid. So this polyatomic is bonded to a hydrogen, and so forth. So sodium hypochlorite is in bleach, copper 2 sulfate is a fungicide, sodium carbonate is in laundry detergent, and ammonium nitrate is in fertilizer. Okay, and this is actually two polyatomic ions bonded together here. So we're going to talk about the ionic bonding with polyatomic ions. They occur in the same manner as what we did yesterday. So we're going to use the crossover method. Okay, be sure that the charge that is crossed over applies to the whole polyatomic ion. If the charge is greater than 1, you're going to use brackets around the polyatomic ion to indicate the number applies to the whole ion. And I'm going to show you that. If the formula uses ammonium, so that's that ion right here, it has a positive charge. Okay, so our positive charges always go first. Okay, and then the negative charge is second. All right, so here's my example. So we have Na, sodium, and then we have NO3, and its overall charge is -1. So we put our charges over top of our our element symbol, so that Na is 1+, and we can see that by looking at our periodic table. So if we look at Na in the top right corner, it gives us the charge. That's what we want. Okay, and NO3 has a negative charge right here, so you put the -1. Then you do the crossing over. Okay, so the 1 comes down here and the 1 comes down over here. And what we get is NaNO3. My second example is with magnesium and that polyatomic ion. So magnesium has a charge of 2. NO3 has a -1 charge. It's right here attached. And then you do the crossing over. So the 1 comes down here and the 2 comes down into this corner. Now, since this charge is bigger than 1, we have to put this entire ion, okay, in brackets and then put the 2 on the outside, just like this. That means this 2 applies to each one of these inside. Okay, and if we were counting atoms, this 2 would multiply the 3, so you would have 6 atoms of oxygen and you have 2 atoms of nitrogen and 1 of magnesium. Okay, so we're gonna try these out. All right, so we need magnesium. Now it's got a charge of 2+. We can see that on our periodic table. ClO3 has a negative charge, so that we're going to put a -1 at the top, and I can see it right here. Then we're going to be doing our crossing over. And since this charge is bigger than 1, we have to put the ClO3 in brackets with the 2 on the outside. Okay, so Sr and PO4, so its charge is a 3 negative. And I'm going to have to take a look at SR's charge. Take a look here. It's a 2 plus strontium. So it is a 2 plus. Okay, and that's going to come down here, and that's going to come down here. So we're going to get SR3, because this charge here comes down to the corner. And this is bigger than 1, so we're going to have a PO4, 2. Then we have aluminum, and that's a charge of 3 plus. You see that on the periodic table. The SO4 has a charge of 2 negative. And I can see that. If it's not provided to you, I can see it on my periodic table. So what you have to do is you have to come down to here, and you need to look for SO4. And here's SO4 here, and it tells you the charge in the corner, and this is sulfate. So we're going to do a cross. Aluminum gets the 2, and the SO4 gets the 3. Now here's our polyatomic ion, NH+. I can see that I have more than 1 here. So what you can do is you can take a look at your chart on your periodic table, NO4 plus 1, and you can see that it's ammonium, and the charge is +1. So it comes first instead of second because it is positive. It has a positive 1 charge, so it comes first. And that Cl actually has a negative charge of 1. You can see that on the periodic table. So these cross, and since they're 1s, you don't have to write them. So you get NH4Cl. So naming these compounds, okay, so since it's made up of a metal ion and a polyatomic ion, you have to name them in this way. You name the metal ion first, and then the polyatomic ion second. So for example, we're going to do sodium first, okay, and you can see how there are 3 elements here. Okay, that's a good indication that we have a polyatomic ion, and it's right here. So if you don't know what that is, okay, you just look at your periodic table and you're looking for OH, and it's right here, and you just write what the name is. There's no changing of anything, you just write what you see in this chart. So it's hydroxide. Okay, so if you have any questions, please let me know. What I would like you to do is to complete the worksheet that goes along with this lesson and submit it to the assignment icon. If you have questions, please let me know and I can help you. Okay? Have a good day.